The marker squeaks as it drags across the whiteboard. A line of digits forms, black and sharp, like a fresh tire track. The lab air tastes faintly of ozone from overworked power supplies, and the ventilation hisses with the steady patience of an aquarium pump. Outside, through a high window that never opens, the city rehearses midnight, distant bass, laughing voices, the dry crackle of early fireworks that sound like someone snapping rulers in the cold. Inside, there is no countdown. There is only the printer's periodic cough and the quiet glow of monitors that refuse to celebrate. Two numbers sit on the board like two bodies at a crime scene. They do not match. They do not even want to match. One is higher, one is lower, and both arrive dressed in the same immaculate suit, uncertainty bars, caveats, careful calibration. The thing that breaks is not a cable or a cryostat seal. The thing that breaks is the room's shared assumption that the universe runs on one clock. Footsteps approach, two teams, two sets of laptops, two different ways of looking at the same cosmos. Their breath fogs faintly near the door as they enter, carrying winter air and confidence. Someone sets a thermos down, coffee smell blooms, bitter and alive. The first team points to their plots, smooth curves, tight scatter. The second team does the same, their points no less disciplined. Their voices stay level, professional, almost gentle. But when the values are spoken aloud, the social temperature drops. Not the actual Celsius, this is subtler. Conversation freezes at the edges. Even the ventilation seems louder. The silence becomes a third instrument, measuring something no detector is built to catch: discomfort. I stand with a marker cap between my fingers, rolling it like a coin. The whiteboard becomes asphalt in my mind, and the gap between the numbers becomes a chalk outline. The suspect is not a person. The suspect is the universe's expansion, how fast space itself stretches, how quickly distance inflates between galaxies like dough rising when no one watches. This is not a debate about style. It is a discrepancy that refuses to die. A decision lands with the calm weight of a gavel. Treat it like a crime. No assumptions get diplomatic immunity. No sacred cows get to graze unexamined. Everything gets audited. The first witness waits nearby, warm, close enough to touch with telescopes that feel almost human. It speaks in pulsations and explosions. A star swells and contracts, keeping time with its own bright heart. Each pulse is a metronome, a lighthouse beam that turns the dark into a measurable rhythm. These are Cepheids, and they sit in galaxies like living yardsticks. When the cadence slows, the star shines brighter. When it speeds up, it shines dimmer. The relationship feels intimate, like learning someone's mood by the speed of their footsteps. I watch photons arrive from one of these stars after a journey that begins before anyone in this lab is born. They hit the detector with soft, obedient clicks. The telescope's coolant lines sweat cold, and the instruments hum with the antiseptic precision of a hospital. We translate those clicks into brightness, then into distance, then into a rung on a ladder that climbs outward. Therefore the universe becomes a place with measured steps, from parallax, the tiny wobble of a nearby star against the background, to Cepheids in neighboring galaxies, to supernovae in galaxies farther still. A supernova is not a candle in any poetic sense. It is a detonation that briefly outshines a whole galaxy, a white-hot scream that turns a dead star into a flare gun. When it happens, it leaves a signature, type I, like a familiar handwriting on a note. The light curve rises, peaks, falls. We standardize it the way a detective standardizes witness statements, correcting for known quirks, testing for consistency, discarding outliers that smell like contamination. Dust hangs between us and the explosion, and dust is a liar. It reddens the light, dims it, whispers that a far thing is farther than it is. Therefore we model the dust, map it, argue with it, subtract it like a bad influence. The nearby witness testifies with breath in its voice, messy, contemporary, full of local details. It says, the expansion rate is high. Space pulls away faster than the other method claims. The number sits there on the board, ink dry and stubborn. The second witness waits so far back in time that far stops meaning distance and starts meaning history. It is the universe's afterglow, the relic light from when everything is hot enough to make atoms impossible, when electrons roam free and light cannot travel straight because it keeps scattering off charged particles like a pinball. The cosmos is a dense fog of plasma, and the light is trapped inside it, ricocheting, losing direction, waiting for the day the fog clears. Then the temperature drops. Protons catch electrons, atoms form, and suddenly the fog turns to glass. Light breaks free. It streams outward in every direction, and the universe keeps that moment like a photograph sealed in resin. That ancient light stretches with the expansion until it becomes microwave radiation, faint, everywhere, arriving at Earth like the hush after a distant explosion. The detectors that listen for it do not smell like dust and coolant. They smell like solder and cold metal, like electronics warm just enough to be alive. This witness speaks cleanly. It speaks in patterns, tiny temperature models across the sky, a quilt of slightly warmer and slightly cooler patches. Those patches are not random. They carry acoustic scars, ripples from pressure waves that move through the early plasma like sound through air. A compression here, a rarefaction there. The universe rings like a bell made of hot gas, and the afterglow freezes that ringing into a map. Therefore the patterns encode distances and scales, a cosmic ruler laid down at infancy. From that map, the early witness testifies about the expansion rate today, indirectly, through a chain of inference, how matter clumps, how radiation influences growth, how geometry shapes the way angles translate into distances. This chain feels colder, older, less personal. But it is precise. Its uncertainty bars sit tight, like a well-tied knot. And it says, the expansion rate is lower. 2 witnesses. 2 stories. Both coherent on their own. But when I put them in the same room, when I compare the 2 numbers, the harmony snaps. The gap remains. So the audit begins the way a good interrogation begins, not with accusations, but with details. I move through the nearby method first, because it is the one that touches actual objects, stars, galaxies, explosions. I run my eyes along calibration steps like a fingertip along the seam. Parallax, the wobble of a star as Earth orbits the Sun. If the parallax is off, everything above it leans. Gaia's measurements come in like a new set of fingerprints, clean, high precision, the kind that makes older data look like a smudged mirror. Therefore parallax should anchor the latter with authority. But the gap holds. Cephids, do they all behave the same? Metallicity, how much heavier elements sit in their atmospheres, changes opacity, changes brightness, changes the inferred distance. If I misread that, the latter skews. Therefore I cross-check Cephids in different environments, different galaxies, different chemical histories. I watch analysts argue with each other's priors. I watch them run simulations that spit out artificial Cephids with known properties, then see if their pipeline recovers the truth. The pipeline behaves. The gap holds. Supernovae, are they truly standard? Their progenitors vary. Their host galaxies vary. Age, dust, local star formation, each is a possible thumb on the scale. Therefore I split the sample by host type, by color, by light curve shape. I search for a correlation that would make the high number an artifact of selection. Perhaps we preferentially detect brighter explosions farther away. Perhaps we miss dim ones. Perhaps the sample is biased toward a certain population. The data resists the trap. The gap holds. The early method also gets its own interrogation. The cosmic afterglow is clean, but clean things can hide the deepest assumptions. I stare at the parameter space the way a detective stares at alibis. The model includes dark matter, dark energy, baryons, radiation, neutrinos, ingredients in a recipe we call standard because it works, not because it feels complete. If one ingredient is wrong, the inferred expansion rate shifts. Therefore I poke at the ingredients one by one, checking if the afterglow's fit is too perfect, too eager to accept a flawed story. Foreground contamination. The Milky Way emits microwaves, dust emits, electrons emit. Those signals layer over the relic light like fingerprints on a photograph. Therefore the maps get cleaned with multi-frequency observations. What stays constant across frequencies is likely cosmic, what shifts is likely local. The cleaning algorithms become a kind of forensic chemical wash. I watch residuals. I watch null tests. They behave. The gap holds. Instrument calibration, beams, noise, system temperature. A misestimated beam width smears the sky, shifts the power spectrum, changes inferred parameters. Therefore every telescope team obsessively measures their beams with planets, with bright sources, with internal calibrators. I track the calibration chains like evidence tags in a courtroom. The chains hold. The gap holds. Every time an error should collapse the discrepancy refuses. The villain does not run. It stands there, calm, daring me to blink. The night deepens. The lab lighting turns the whiteboard into a pale stage. It is 2:13 a.m. Outside, the party whistles rise and fall, distant and thin, like birds that forget the season. Inside, the plots on the wall glow in blues and reds, likelihood contours, residuals, corner plots where parameters pair off like suspects in a lineup. I feel the fatigue in my eyes, a gritty film that makes the monitor's whites bloom. The question is no longer, which team is wrong? The question becomes, which assumption is brittle? Because brittle assumptions do not announce themselves with a crack. They masquerade as common sense. I take a fresh board. Not the one full of numbers, the one full of stories. I write suspects at the top. The marker smells sharp, solvent, and plastic. The universe is the defendant, but the theories are the people in the room who might be lying to themselves. Suspect A arrives first, dramatic and tempting, early energy. A component that flares briefly in the young cosmos, like a firework that goes off before the main show. It adds pressure, it speeds expansion early, it changes the size of that acoustic ruler imprinted on the afterglow. Therefore, when we use the afterglow to predict today's expansion, the prediction shifts. This suspect has a clean motive. It reconciles the two clocks by altering the calibration of the early universe. But it also leaves fingerprints. Extra early energy changes structure formation, changes lensing, changes the way galaxies cluster later. Therefore, I look for the fingerprints in large-scale structure surveys, in weak lensing maps where foreground mass distorts background galaxies into subtle arcs. Early energy can hide, but it cannot be invisible. Suspect B slips in like someone who never touches the door handle, unseen particles. Extra neutrino-like species. Dark radiation. Something that free streams through the early plasma and changes the expansion rate when the universe is young. It shifts the balance between radiation and matter, changes the time when the cosmic fog clears, changes the pattern in the afterglow. Therefore, the inferred Hubble value moves. This suspect leaves a signature too. It affects Big Bang nucleosynthesis, the primordial ratios of helium and deuterium. A single extra species makes helium climb. Therefore, I cross-check with measurements from ancient gas clouds that absorb quasar light like translucent ink. The abundances constrain the room this suspect can occupy. The suspect does not vanish, but it loses space to maneuver. Suspect C is the one that makes even seasoned investigators sit up straighter, gravity itself. The law that holds planets in orbit and keeps us pinned to Earth might behave differently across scales or epochs. It might look like Einstein near the Sun but deviate across cosmic distances like a ruler that changes length depending on who holds it. Therefore, the growth of structure changes, clusters form differently, lensing differs, the relationship between mass and light shifts. This suspect is dangerous because it can impersonate other effects. It can dress like dark energy, talk like dark matter, and still be a different creature. But it also faces hard interrogation. Gravitational waves arrive from colliding neutron stars, and their signals travel through space-time like ripples across a pond. If gravity behaves oddly, the speed and damping of those waves changes. Therefore, detectors like LIGO and Virgo become unexpected witnesses, listening to space-time scream and checking whether it matches the script. Suspect C sweats under that kind of light. Suspect D arrives last, unglamorous, wearing a beige coat, the mundane monster. A systematic error that hides in standard candles, dust models, population assumptions, or selection functions like a counterfeit bill in a thick stack of cash. This suspect does not require new physics. It requires humility. It whispers that our telescopes, our pipelines, our statistical choices smuggle and bias. Therefore, I interrogate the data reduction code as if it is a witness with a stutter. I hunt for priors that quietly push answers upward. I look for human choices that become invisible once they turn into defaults. I pull on the thread of sample selection, which supernovae enter, which ones get cut, and why. I rerun fits with alternate light curve models. I ask how calibration drifts across years, across detectors, across filters. This suspect has the strongest alibi, common occurrence, and the weakest glamour. But it is also the one most likely to be guilty in a human investigation. The board fills with arrows and notes. Each suspect connects to different evidence. The gap between the two numbers becomes leverage. It is no longer merely an embarrassment. It becomes a crowbar. Because a mismatch this persistent forces theories to expose their seams. The eureka is not a single triumphant answer. It is the realization that the tension is now strong enough to be useful. The discrepancy becomes a tool. Whichever suspect survives every cross-examination wins reality. Therefore, the strategy changes. Instead of pleading for agreement, we weaponize disagreement. We design tests that do not care about the ladder or the afterglow alone, but slice through them both. Gravitational lensing becomes one such blade. A galaxy cluster sits in space like a boulder on a trampoline, and light from galaxies behind it bends, stretches, multiplies into arcs. The amount of bending depends on geometry and mass distribution, therefore on the expansion history. If the universe expands one way, the lensing distances align. If it expands another way, they do not. So we watch background galaxies smear into crescents, and we measure the shear with algorithms that treat each faint smudge like a fingerprint. Baryon acoustic oscillations become another blade. Those early sound waves leave not just a pattern in the afterglow, but a preferred clustering scale in the distribution of galaxies, a faint, spherical echo. Galaxies today are not placed randomly. They carry a memory of that ruler. Therefore, surveys map millions of galaxies, redshifts turning into a three-dimensional scaffold of the cosmos. In the data, a subtle bump appears at a characteristic separation, like a heartbeat in noise. That bump is a ruler we can hold up at different redshifts to see how expansion stretches it. Time delay cosmography becomes another. A quasar flickers far away. Its light passes by a massive galaxy on the way to us, splitting into multiple images. Those images flicker with delays because each path has different length and different gravitational time dilation. Therefore, by timing the flickers, watching one image brighten, then another days later, we infer distances and expansion. Here, the universe provides its own stopwatch, and we stand there with our own clocks trying to keep up. Standard sirens enter the room with a new kind of testimony. Two neutron stars spiral together, their gravitational waves rising in pitch like a siren in fog. The waveform encodes distance directly, no distance ladder required. If we also see an electromagnetic counterpart, we get redshift. Therefore, we get an independent measurement of expansion, one that does not share the same biases. It is the kind of witness a detective dreams of, not connected to either suspect's social circle. But the events are rare, and localization is hard. Therefore, patience becomes part of the method. As these blades sharpen, the story gains a different emotion. The discomfort becomes anticipation. The gap is no longer an awkward silence. It is a charged wire. I step outside for air. The door releases a rubber seal sigh. The cold bites my cheeks immediately, clean and brutal. The street smells like smoke and champagne, the aftermath of early fireworks and spilled celebrations. Somewhere a group counts down to a midnight that means nothing to galaxies. Their voices bounce off brick walls. I look up and the sky is a dark bowl, stars faint through city haze. Midnight approaches, the humankind, the easy kind, a number that flips because we agree it does. But inside the lab, midnight does not arrive cleanly. The universe keeps two times. One clock ticks from nearby explosions. Another ticks from ancient afterglow. They disagree about the pace of the cosmos right now. That is the philosophical cut. Cosmology is not bookkeeping. It is a live investigation. The implication spreads in my mind like ink in water. If the standard model of cosmology is incomplete, the missing piece is not a footnote. It is a missing character in the cast. Something in the early universe may flare and vanish. Some particle may roam unseen. Some modification to gravity may slip into the equations like a forged signature. Or some quiet systematic may hide in our instruments like dust on a lens. Each option changes the story of everything, how structures form, how fate unfolds, whether expansion accelerates forever or shifts in ways we do not yet imagine. But clarity arrives with the cold air. When two honest methods disagree, nature offers a door. The tension is the handle. Therefore I walk back in. The lab warmth wraps around me, smelling again of coffee, plastic, and faint electrical heat. The whiteboard waits. The two numbers wait. A hand itches to erase, to restore neatness, to make the room comfortable. But I do not erase them. The mismatch is evidence. Evidence does not get erased because it offends the theory. Evidence gets preserved because it offends complacency. The printers keep coughing. The ventilation keeps hissing. Outside, fireworks finally bloom in earnest, their flashes strobing faintly through the window like distant camera shutters. In the lab's glass reflection, the bursts look like silent supernovae, tiny, local, celebratory imitations of the cosmic violence we use as rulers. I stand at the board and leave the two numbers intact. They sit there like twin midnights, two times that both claim to be true. The universe, under audit, refuses to reconcile them on command. Therefore the next move is not to demand agreement, but to design the interrogation so sharp that only one story survives. The synthesis settles into a single, timeless truth. Reality does not owe us consistency across methods. It offers consistency only after we learn which questions we are truly asking. The mirror turns toward you, right now, wherever you sit. Two clocks in the universe echo the two clocks in a life, the story you tell yourself about what is happening, and the measurements you cannot ignore, your sleep, your stress, your data. When they disagree, the instinct is to pick the comfortable clock. But the door to change is always hidden in the disagreement. The next question hangs in the lab air like the lingering smell after a firework. If the universe keeps two times, what else in the cosmos is quietly out of sync, waiting for a sharper audit to reveal the missing piece?